We're going to continue talking about Fischer projections and how to manipulate molecules and, for example, go from a wedge and dash representation to the Fischer projections. So let's start drawing one molecule in the wedge and dash form. So I'm going to do just label carbon 1, 2, 3, and I'm going to have carbon 4 here. And then I'm going to have different substituents. Let's say that I have here A on the dash, B on the wedge, and here I am going to have substituent D and substituent E. So that is your wedge and dash. Both of these centers, C2 and C3, are chiral centers. They have 4 different substituents, each of the carbons. Now, from your wedge and dash, we're going to do what we have done before. And so we'll say, this is wedge, dash. And let's going to, instead of having this like that, we're going to tilt it a little bit. And this is going to be your sawhorse projection. So this, I'm going to draw, let's draw just a line that is a little bit inclined. And that is C2, and that is C3. And now you see that going up here, you have C1, and say my view is here. I have on the right side, I have B, and here I have A. For the carbon tree, here I have now C4 below, and I have here A and D. So that is a sawhorse. Now let's do the Newman projection, but I'm looking at that, say carbon 2, and the bond that connects carbon 2 and 3. Same thing here. That's my eye, only that's a different view, so through that bond. So what I see in the front is carbon 2, and carbon 2 has carbon 1 here, and I have B and A, and then carbon 3 is in the back, it's connected to carbon 4, and now I have D and E. Now from this conformation, I am going to now, once I have that, notice my process was a wedge and dash, I did the sawhorse, I did the Newman. But now to draw the Fischer projection from that, we're going to start from a different, say, conformation of the Newman projection. Newman. And because I am running out of room, I'm going to draw, erase this one and draw another conformation. This one is actually staggered conformation, you see. In, say, for example, if the dihedral angle between carbon 1 and 4 is 180, they're opposite, right? Now, what I want to do to draw the Fischer projection now is I want to draw an eclipse conformation. So I want to keep the carbon in the front the same. So in doing so, I'm going to redraw my circle, right? And let's keep that the same. See, 1, A, and this is A. And now I am going to rotate here, this one in the back, so that now the new dihedral angle in this conformation, the dihedral angle between C1 and C4 is 0. So I have rotated this all the way to be eclipsed right behind C1. And in doing so, we now are going to have, notice here, C4, then if you follow the sequence, D, A. So C4, D, and E. So right now, then, this is also a Newman projection, but now this is eclipse, right? So this C1 and C4, right, C4 right behind C1. And this is, of course, number 2, carbon 3, you don't see. This is carbon 2 in the front. So now from this view, I'm going to show you something with my models. Now, this is a wedge and dash. What I'm going to do now is say that I have this green eclipse. See that here. And now what I'm going to do is I'm going to say, kind of push it towards the screen. What this is doing is showing you why the convention is the way it is. So this is, again, this eclipse conformation, and I simply did this and push it. So what that does is now, erasing this, I'm going to draw my Fischer projection. And in that Fischer projection, again, start from the eclipse of the Newman. We went from the wedge and dash to the Newman projection. And now I had that, and I need to work with the eclipse. Now you will draw your Fischer projection. You have 2 chiral centers, and now you're going to draw this vertical line. And above here you will have C1, that's your carbon 2 here. And then you have carbon 3 is the one behind, and C4 is here. So now see, the carbon in here above is this one here, and it is kind of getting inwards. Remember that the convention that we use in Fischer projection is that these vertical lines are dashes, and these are wedges. So that's the convention. And you see that when you try to push that against the glass here, that these two are getting in. Now, what's on each side? To the right side here, or C1, I have B, and then I have A. So I'm drawing what is connected to C2, that's here. And now connected to C3 in the back, I already drew C4, and then I have D and E, right? And so that's my Fischer projection. And I have shown you the way to go from the wedge and dash to the Newman. And remember that if you don't have the Newman eclipse, you need to do the conformers. So do a rotation so that you have that. Once you have it in Fischer, what you can do many things. You can name the compound either way using any of the projections. You can determine the absolute configuration. And we're going to do that now in molecules with specific groups, not just as generic examples.